All right, problem-solving method for two-dimensional kinematic problems. Uh, well, the first thing you always want to do, determine if acceleration is constant or not. For that, you'll have to examine what you've been given. Sometimes it'll say directly. If it states directly projectile, then you know it's constant. Otherwise, you're going to have to look at what's been given. If acceleration depends on t at all, you'll have to use the non-constant rules discussed previously. If v depends on t squared or higher or some funky function, of time, like an exponential or a sine cosine tangent, then it's non-constant. If the position depends on t cubed or higher in terms of polynomials, or some funky function, then you have non-constant acceleration. So look for those things. You need to categorize that pretty quick in terms of the process. Step 2. I find it always helps to draw out what's happening. I'm not very good at visualizing things, so sometimes it's really helpful to me to draw that out. I recommend you always do it just as a matter of practice, because you want that practice when it comes to problems where you can't visualize it as easily. You want the practice drawing stuff before you have to draw stuff. That's basically what's going on there. 3. This kind of splits. You can either go A, it's non-constant, so you'll have to use integrals, derivatives to get the equation you need after setting up what you know. Or you could have the 3b case, constant acceleration, in which case you'll have 11 parameters and 10 equations that relate them. And let me list out those parameters for you. I've already listed out the equations, so you'll want to refer back to the constant acceleration case. There is basically x initial, x final, y initial, y final, vx initial, vx final, vy initial, vy final, ax, ay, and time. Time is the common thread that runs through the whole thing. Usually what you'll end up having to do with these types of problems is use either the x or y equations to figure out what time something happens at, and then use that in the other set. So let's say you use the x equation and you solve that for t, then you'll use that t in a y equation to get your result. So it's always going to be some pairing of equations, almost always, particularly with projectile motion. Okay, once you've got all this stuff, for A or B, you'll solve the equations for what you need. And I perhaps should have put up as an earlier step, what are you looking for? Because that will drive which equation you use. In the case of constant acceleration, you're being driven by what do I know? And you'll have to find which equations you have enough information that there's only one unknown left in the equation, because those are the equations you'll be able to use to find additional information to solve your problem. This really is going to require seeing some examples. So this is just the general outline of the process. We'll see some examples in class, but this is a good thing to refer back to. You'll actually be able to see me going through these steps as I solve a problem, and I'll be pushing you to go through these steps as you solve problems in class as well. All right, I'm going to stop at that point. Hopefully this gives a sharp enough outline of what you've got to do, but again, you'll see some classroom examples. So we'll stop there and see you in the next one. I think we're going to be getting into uniform circular motion and relative motion coming up soon. Find the stop button.